Thank you all for enrolling into this system programming course. I'm pretty sure I should be able to impart enough knowledge about system programming and Linux and Unix operating system internals and underlying principles so that it can help you in doing any types of system programming or interfacing with the kernels. System programmings are basically the building blocks of working between user space and kernel space. By default, the kernel space, address space is protected from the user space. The user space cannot access the kernel directly. So how do we do that? So this system call comes in between and it acts as an interface between user space and kernel space. So a user wants to write some data to a disk. The disk, being a hardware resource being managed by kernel, cannot be directly accessed at random or in a haphazard way from the user space. So what we came up with is that from the user space we will be calling a set number of APIs, a limited number of APIs. Those APIs will be called as system calls or system call number or system call table, and using that system call you will enter into the kernel space. So if you take an example of a write call, you might have all heard about write, W-R-I-T-E, write, or fwrite, or open, or fopen. All these calls, what it does is it wraps the parameters from the user space, push it onto a stack, and call an interrupt to enter into a kernel space. Let's suppose if there is no system calls, maybe instead of write, you wanted to call something like my pen drive, something like that, append a system call as my pen drive, and if it doesn't exist you will not be able to enter into the kernel. So system calls are the interface between user space and kernel space. What is the language used for system call? All the APIs and libraries which are written for system call is absolutely only in C. That doesn't mean you cannot use C++. You can use to write system calls in C++. However, for all the existing libraries like libc, which supports all the libc related code with respect to open, read, write, and everything, almost everything is part of libc, is written in C. Similarly, if you take the libpthread library, it's written in C. So everything is written in C. However, if you want to put a wrapper, a top level wrapper, and try to use constructor or destructor in an object oriented way, you can use the C++ and wrap the C code to achieve the same. Some of the system calls which we will be covering into this course, and some of them which are very important, is like fork, how to create a process, what are the different variants of fork, how does the PID of a child and parent differs, those kind of things. Then we will look into file operations, handling like unbuffered IO, like open, those kind of calls, buffered IO like fopen, fwrite, fread, reading and write to console, which is your terminal, and socket programming. Apart from this, we will also look into semaphores, mutexes, how to make your program thread safe, how to write a multi-threaded process, multi-processes based on fork, and how to navigate directory, signal handling, and a lot of other fun stuff. We will also look into how to implement a system call and make the corresponding change in the kernel, even though that doesn't comes in exactly as part of system programming, but as part of kernel programming. So system calls has two parts. One is the interface from the user level which talks to the kernel, and then there has to be a corresponding kernel call also. I will go ahead and show you the kernel call also, so that it helps you in understanding the entire system call. Thank you all, and let's directly go into start coding. I will take this course based on the practical approach by demonstrating a small code, so that not to make you confused with a very large code with different calls, but I will try to take one or two APIs, create a code out of that, so that make it as a self-existing example, as a like single example for that particular system call, so as to not to confuse you. Now once you understand the system call, you can intermix many of those calls or several of those calls and create some useful software out of it. So hope to see you in my next video, and we will start coding right away. Thank you all for enrolling into this course once again.